Hi guys, in this lecture we're going to learn polynomials, and this is the second theory part of polynomials, and this is going to be a really it's going to be a bit heavy lecture maybe for a few students who have no idea about Vieta's relation, but for people who have already known Vieta's relation, it's going to be a really interesting lectures, and it's going to be a short lecture of Vieta's relation. And in polynomials you only have two things, which is Vieta's relation, division algorithm, symmetric expressions, and all of them are the whole polynomials, and all you need is algebraic manipulations to solve any polynomial problem. So in this lecture we're going to look at Vieta's relation first, and this Vieta's relation is really important, guys, and we're going to start in just a second. Oh, my video might be a bit dark because I'm recording in the night, so don't look at my video that much, but fine. I'm starting. So let us look for the Vieta's relation. So what Vieta's relation? So Vieta's relation is just the relation between Vieta's relation is nothing but the relation. So let me write it down. So it is the relation between between the the coefficients the coefficients and the roots. So I have a polynomial like ax cube plus bx square plus cx plus d. So and the roots are alpha, beta, gamma, because it's a cubic polynomial. It's gonna have three roots. So I'm gonna give some relation between alpha, beta, gamma, and a, b, c, d. So I'm gonna relate these two somehow. So let us look the relation for a quadratic. So uh, we're going to learn it like step by step. First, let ax square plus bx plus c be a quadratic polynomial. So here I have assumed a cubic. So in the first case, we have assumed a quadratic polynomial here, and let the quadratic polynomial be ax square plus bx plus c. And the roots of this equation are alpha and beta here. As I've given, this equation, the roots of this equation is alpha beta. So I can write this equation as this a into x minus alpha into x minus beta. So many people might have been wondering what is this a here? Why a? So just multiply it. So first don't consider a and just multiply. So what is the coefficient of x and x? So it is x square. So see, I mean, what is the coefficient of x square? So x into x is nothing but 1. The coefficient of x square is nothing but 1. But here we have the coefficient as a. So we have to multiply it by a. So now I'm just expanding this. So like I'm just writing x into x is x square, a into x square, ax square, then x into minus beta, a into x into minus beta, plus a into minus alpha into x. So I'm just expanding everything and writing and simplifying it. So I'll get this equation. So now observe. So I'm dividing the whole equation by a. See, just observe. I'm dividing the whole equation by a because I find a here, and a here. I don't feel comfortable with a, so I'm just dividing everything by a. So here, when you divide by a, this a and this a gets cancelled, and I will get the leading coefficient as 1. So I get x square plus b by ax. So b by ax plus c by a, and here all a's gets cancelled, equal to x square minus alpha plus alpha beta. So now what I'm going to do is I'm going to compare the coefficients. The coefficient of x square here is 1. The coefficient of x square here is 1. The coefficient of x is b by a, but the coefficient of x, oh sorry, so I might have, so the coefficient of x, so here I have missed an x. So the coefficient of x here is minus of alpha plus beta. So after dividing this equation by a, oh sorry, after dividing this equation by a, I will get by a here. I will get b by a as a coefficient of x, and this side a gets cancelled and I get minus of alpha plus beta. So by comparing these two, coefficient of x, I get alpha plus beta equals to minus b by a. I'm just sending the minus sign here to here, and similarly c by a, C by as I have C by A here, and I have alpha beta here, so I can compare both of them directly. So this is the Vieta relation. So this relation of comparing the roots to the coefficients is called Vieta relation. So we have seen for quadratic. So I have written the text format here. So if you don't understand the handwriting well, you can look at the text here. Say I've written the same thing. So this is from my handout. This is from my handout. So I've copy pasted the same thing, and let's go to the next one. Vieta relation for cubic. So same. I'm assuming a polynomial of cubic. Uh, so it's ax cube plus bx square plus cx plus d, and the roots be alpha, beta, gamma. But through fundamental theorem of arithmetic, there can only be three roots. Might be irrational, might be imaginary, might be real. So I'm dividing the whole thing by. So I can write this polynomial as, so the same way how we have written for quadratic, we can write it for cubic also. I'm writing it as a into x minus alpha into x minus beta into x minus gamma. So divide everything by a. So here the coefficient is 1 plus b by a plus c by a and d by a. And here a gets cancelled directly. And x minus a into x minus b into x minus c. So when you simplify this, when you open this and expand, you get this equation. So now again you can compare. Now compare b by a equals to minus of alpha plus beta plus gamma, and c by a is nothing but alpha beta plus alpha gamma plus beta gamma, and d by a is nothing but minus of alpha beta gamma. So you just got to remember all these. So you just need to remember. So now by saying the general form, because if you have seen, we can't just say the Vieta relation for after cubic. We can't just again give for biquadratic, then fifth degree polynomial, then sixth, seventh, eighth. Obviously, it's not possible to learn. So if you have seen, so we are just generalizing the Vieta relation. We are generalizing the Vieta relation. So the Vieta relation is, so if you have observed, so here we have alpha plus beta plus gamma. Here we have alpha beta plus alpha gamma plus beta gamma. So here one root is taken at a time, and here two roots are taken at a time, and here all the roots are taken at a time. So the sequence is like that. First one root is taken at a time, then two roots are taken at a time, then three roots are taken at a time, then afterwards four roots are taken at a time. Two roots are alpha beta plus alpha gamma plus beta gamma. So the same thing, I've written it here. General form. First, one root is taken at a time, then two roots are taken at a time, then three roots are taken at a time, then four roots are taken at a time, and the last term, which is might be some k naught. K naught will be product of all the roots: alpha, beta, gamma, delta, theta. I don't know any other Greek things. Delta, omega. So there are many, I don't remember more. So you can even prove it by induction. It's a really easy proof which is not required for IOQM. You can prove it through induction. And see, here minus b by a. So the roots are always changing. First you'll have a negative, then you'll have a positive sign, then you'll again have a negative sign. So the roots are like changing, minus plus minus, and the roots are one at a time, then two at a time, then the roots are taken three at a time, then four at a time, and so on, 5, 6, 7, 8, so on. So this is a Vieta relation. So so for Vieta relation you need some basic things, basic sequence and series. Obviously sequence and series will be taught in depth, but we need some basic sequence and series for the polynomials. So in an arithmetic progression, arithmetic progression is nothing but first 2, 4, 6, 8, 10. It is constantly increasing by 2. So here, because it's constantly increasing by 2, I say that the common difference is 2. So in an arithmetic progression, you'll have the common difference as d. So here, the common difference is a A plus D, A plus 2D, A plus 3D, so on. Here's D is a common difference and A is the starting number. Like 2, 5, 8, 11. So 2 is the starting number and 3 is the common difference. So strategy. So this is strategy point. So when someone asks us to just close your eyes and just think about when you're asked to when I ask you that assume three numbers in AP. When you assume three numbers in AP, what do you assume? You assume A plus D, and A plus 2D. So think in a different way. Think in a different way now. Why can't you assume the three numbers as A minus D, A, and A plus D? Why? Why do you want to observe? See, but why do you want to think like that? It's a really hard point to remember. Like not like to remember. It's a hard point to think about it on your own. So, but when you add all these three, here minus d and plus d gets cancelled, and you get 3a. So now they say the sum of three in an arithmetic progression is 12. So what you can directly write it as a minus d, a and a plus d equals to 12, 3a equals to 12, and a equals to 4. So you have directly got the middle term without any manipulation. You just need to manipulate one small thing, which is a minus d, a and a plus d. So I've given some theory, and this is a example question, guys. And for geometric progression, so same from geometric progression. So if you observe 2, just observe the numbers what I have told. 2, 4, 8, 16, 32, 164, 128, 512, 1024, 2048, 4096. What are all these? All these are the 2 power. It is 2 power 1, 2 power 2, 2 power 3, 2 power 4. It is increasing 2 times. So first is 2, then 2 square. I'm multiplying it by 2. Then I'm multiplying it by 4. Then I'm multiplying it by 2 cube, which is 8. So it's all these are called as GP. So in a GP, if so, let us look at the strategy point. You can look at the theory here. It's like a simple theory. So strategy point, if you're assumed, if you're asked to assume 3 points in GP, then what would you assume it as? Again, close your eyes. So 3 points in a GP. Don't assume like minus AR square minus AR plus A plus AR square. In a GP, if you see that we are using multiplication mode, assume A by R, A and AR. So when you multiply all three of them, you get A cube because R and R gets cancelled. So you get A cube, so the R gets cancelled. So we always want two variable things to come to one variable. So for an AP you need to add, but for a GP you need to multiply. That's the basic point where people struggle to think about it. Here I did not think about it until and unless few people told. And harmonic progression is uh, nothing but like in AP you get 2, 4, 6, 8. All these are 2, 4, 6, 8, 10, 12, 14, 16, 18, 20 are in AP. So if you take the inverse of the AP, you get a harmonic progression like 1 by 2, 1 by 4, 1 by 6, 1 by 8. So 2, 4, 6, 8 are in AP, then 1 by 2, 1 by 4, 1 by 6, and 1 by 8 are in HP. And this is inequality. So I'm just telling you the basic because it might be necessary uh, in solving question. So just a second. So you just need to remember this. For real numbers, for real and positive numbers, for real and positive numbers, a plus b plus c plus d, so on, by, if there are n numbers, by n is lesser than equals to nth root a b c d, so on, is less. So you don't need to remember this. You can just ignore this. So if you know these, if you know this one, it's more than enough, guys. If you know this one, it's more than enough. In the next lecture I would be making you solve problems on this. So when you solve problems on this, you'll clearly understand why I have used this. And this is known as the Amgm inequality. This is known as the AMGM inequality. So this is even true for you can this is even true for a plus b by 2 is greater than equals to square root of ab. So I'm gonna I think I'll prove it. So a plus b whole square is greater than equals to 2ab. This is obvious. You should know this. Then I am taking the square root of. So what I'm doing, actually the proof is not necessary, guys. You will get totally confused for the proof. So you can go through this one. You can go through this one. So this is, I'm not supposed to explain you at all because this is really basic stuff and you should know. So I want you to go through this one because you can't expect me to tell all the basics because you at least need to know till 7th or 8th level, 7th class or 8th level to attend my lectures because IOQM needs some stuff. So that's it, guys. In the next lecture, we're going to do problem solving, and I would have already posted you an handout. I don't know when I would be posting this lecture because I'm recording this lecture. Maybe it's October. I'm recording this in October, so I don't know when you're gonna watch it. So if you have made it till here, if you have watched the whole video, please subscribe to my channel and thank you for attending. Thank you.